Hello, welcome back to another video where I get to work on my programming language, Natalie. And welcome to so many of you who this week subscribed, 50 something of you. Thank you so much. I'm in shock, and I didn't think that many people would be interested in a subject like this. So yeah, cool. Welcome. And thank you for Andreas Kling, who gave me a shout out. And a lot of you came from that, I guess all of you pretty much. And yeah, thank you, Andreas, for the encouragement. And this is hard, right? Is like exposing my inner thoughts as I program to you guys of what I'm working on. And as I was realizing people were going back and watching some of my videos, I went back and watched a couple, and it was just so cringy. And it's just me. That's just how I am when I watch myself. I think a lot of people are like this. You go, oh, I said that, or like I sound like that, or whatever. Why do my hands move when I talk? But you know, that's just who I am. And so thanks for letting me share myself with you and what I'm working on. Thank you for your interest in it. And so it's hard, right? When you are exposing your thoughts and you realize like, oh, I'm about to say something that I'm not sure of, or I might be wrong, or if you're just programming as I do, I'm a remote programmer. Even if I weren't remote, if I'm in an office, it's not like people are watching over your shoulder every time. And so you you may not want people to know how much you Google things. That's sort of like a guarded secret, right? Like people know you Google things, but they may not know how much you Google stuff. So it's hard. Like in the last video, I said something about a signed char pointer and an unsigned char pointer, and not really understanding what happens when you cast one to another. And in the video, I was thinking I shouldn't say that, but I think I should. I should just be honest. And I probably should have Googled it and figured it out in the video, because we need to be honest with each other. I think that's how so much bad software is written, is because programmers pretend like they know it all. We should be honest and just say, I'm not sure, let me Google it, and instead of guarding that so much. So anyway, speaking of that, I have a couple things to talk about. One is the char pointer thing. I did some experimenting and Googling, and I just kind of had to figure this out for myself and remind myself that the bits underneath don't change, right? So when you cast something from one type to another, it's not actually going in and fiddling with bits. It's just how the compiler is interpreting those bits. And so in the case of a character pointer, if you have a char pointer, which I believe on my platform is signed by default, or an explicitly signed char pointer or an unsigned char pointer, then it doesn't matter. It's still a string. And so I had to write this program to sort of prove that to myself. And so what I did was I started out with this string that has a multi-byte character in it, this heart, and like see what happens when you cast it from one thing to another. So I just basically cast it to a signed char pointer and an unsigned char pointer, and then I cast it back to a char pointer from those. And I just printed all those out. And yeah, so I mean, actually, if we just put these kind of right after where they are, like that, and we do gco car.c car, and so you can see it prints out the same string regardless. It didn't fiddle with any bits, and the only thing that really changes is how we're interpreting the individual numbers. So an individual number, or an individual character, when represented as a number, here I'm printing it out as an integer. In this case, the C3 is actually interpreted differently. It's interpreted as a signed number, and so it's 226 instead of -30. And so the only time it would really make any difference is if you're looking at individual characters in that way as numbers, and you want to, you're not printing them, you want to see if it is a certain number. So I need to keep that in mind. And so I wanted to clear that up in case, in case that wasn't clear. So there's that. And then I guess we're done with this. So let's go to Ellie and clear that. And I had to change quite a few things to get the Onigmo library compiling correctly. And one of the boo-boos I did in the last video was I had run make install on the Onigmo library, and it had put it in user lib, so user local lib, which is where all the library stuff goes, right, on your system. And so everything compiled fine on this system, and then I took it to my other. I have a Windows machine that I like, a little tablet that I use, and nothing worked. And even though it has Ubuntu, it has Windows subsystem for Linux, and it has Ubuntu and all that stuff, but none of it worked, none of it compiled. And so I had to figure out that I had made a boo-boo, and so I wanted to kind of go over that. So the main one was this library path. I had not set that correctly, and I had not so it wasn't looking in the right path, and so now I've set that properly, and I had to make another change because I want this statically linked so I don't want it to dynamically link in the Onigmo library. So I don't want the end user to have to copy that file to somewhere. And so the way I had to do this for both Clang, to make Clang and GCC happy, was instead of doing -l Onigmo, which lets the compiler decide if it's dynamic or static, I basically just put the full path to the .a file here in the command. And the order of these turned out to be important because, where am I at? Actually, at first had it here at the end, which worked in GCC but not Clang, or vice versa, I don't recall now. And so I just kept experimenting with the order of the libraries until it worked. And this actually makes sense. This is kind of, I don't know, it kind of makes sense that it's in this order, but I still don't fully know why. But it's aesthetically pleasing that it's in this order. So there's that. And then the other change I made was to get the REPL to work. This is going to be a running joke of my video stream, is how many times I have to commit fix REPL, fix REPL, fix REPL, fix REPL, fix REPL. So I think I'm at like 5 now. So it seems like every project I work on, I have to make a commit later called fix REPL. But in this case, to do that, I did with pick on the Onigmo library. When I run configure, I passed with pick, which is position independent code, and that tells the compiler to compile the library in a way that jumps are relative instead of absolute. And that is needed because of how our REPL works. The way our REPL works is we actually we compile every time you run a line of code. If I do this and I type 2, then it's writing some C code and compiling that as a shared library. And then we use fiddle in Ruby, which is a FFI wrapper, and we do a DL open on that shared library, and then we evaluate the compiled function. And so in order to compile the shared library in the make file, what I had to do was compile Onigmo with position independent code. And so that was a new thing for me. I knew about position independent code a little bit, but I didn't know you could pass it to a configure script. So there's that. Okay, all that out of the way. What I wanted to work on tonight, I have a little bit of time, is to just add some more to our regex library. And I learned recently that Some people call it regex, and I call it regex. And so I'm curious, when you grow up learning things and reading things on the internet, you don't always hear the right way to pronounce it. And so I'm curious, how do you pronounce regex or regex? Comment below if you have an opinion. There's probably one right way, and I'm probably doing it wrong. So if we look at regexc, and Ruby calls it regexp with a P. The only thing we really support is new, inspect, and then the equal tilde, which in Ruby is that, right? So it'd be cool if we could add two things in this session, which is the dot match. So if I have foo dot match on a string, then it returns this MatchData object. And the MatchData object, I believe, kind of refresh my memory here. I thought maybe you have to do 2a. Yeah. I'm just curious. What methods does... what do you mean? Oh, methods. Okay, so it has a handful of methods on this MatchData object, and we don't have to do all these tonight, but, oh, captures, that's what it's called. Captures. Yeah, so, yeah, I mean, we can either implement 2a or captures, but that's super useful, is to be able to pull out the match groups. I always call them groups, but captures makes sense. Oh, named captures. Oh, interesting. There's all kinds of fun stuff here. So we won't get to all of this because a lot of this is just going to be wrapping the library, but I think making the MatchData object will be interesting and hopefully fun. So let's get out of there. And it's going to be a method on string. I wonder first, though, should we implement the MatchData? So MatchData. What is its superclass? Is it just an object? Yes. And it doesn't even have a new method. That's interesting. So I'm going to say that it's created internally, and you can't even create one manually unless, yeah. Okay, fair enough. Let's work on creating that. Is there a way to... Sorry, let me complete a sentence. Is there a way to get one in any other way? Does that even make sense? So the only way I know to get one is to call .match. Can you call match on a regex? Yeah, okay, so you can call regex.match or string.match. Those are the two ways I know to get a MatchData object. Okay, so let's just create our MatchData object, and we'll create it right here. MatchData, oops. And it is a subclass of object, and we're going to set it as a constant on object, like so. And I'm curious, does it have any instance variables? What if I do some sort of group? Okay, so it doesn't have any instance variables. Everything's stored inside of it. So, so let me complete that sentence. Everything's stored in a way that it is not exposed to Ruby. Ugh. So it's, I wonder if this is even right. It's going to be, yeah, it's going to have its own value type in this enum here. So That's currently how I store data in an object that is not just a generic object, is to make a new one of these, and then to go down to this God object that we have, the object that represents everything, and then making another item in this union here. It doesn't take up any extra room because it's a union. It just gets all squashed together. It takes up the same space. And so I guess I need to do nat value match data, and we're going to say this is, what is this? What is it going to be, right? So I guess I need to go look at the Onigmo library. Yeah, let's go to the sample. What does it return? I don't know what's happening with my internet connection. Or maybe it's GitHub. Something is slow. Oh, come on. What does it return in terms of a match? So this R is a number that just has the state. Region is where it stores, let's see. Number of regions. Wait. That's a peculiar. Okay. I guess these are the matched groups, I think. Let's just run that sample. So sample simple, cd sample. Oh goodness, this is gonna be, I hope I get all these flags right. .libs, Onigmo, and then I want to compile the simple.c, compile it to simple. Okay. Yeah. This is what I fought the other night with Clang a lot. Was even though I'm telling it where to look for the library, it chooses to make it as a dynamic library. So the way that I know to do this is to do .libs, lib onigmo.a like that. And there, that works. Okay, so oops. We'll just look at it here. What is the pattern? What is it spitting out? 4 through 14 and 5 through 13. Zero, 1, 2, 3, 4. So starting at A. Okay, so yeah, so the first region is the full match of this A dot star B, which matches on A, F, B, and then this parenthesized group, this capture group, matches all the Fs, and that corresponds with these indexes, right? And then the match is at 4. Where do we print that out? Match at 4. So R is just the number of where it began in the string. And then this region thing is the data structure for how we pull out the capture groups. Okay, very cool. What does range do? What does range do? Oh, range is just a pointer to, I think we talked about this in the last video, a pointer to the end of the string, essentially. So we don't care about that. So I think what we want to store in our object is this region, and that's this. Yeah, and so what type is that? Onigmo region. Okay. So let's just put that there, and we'll say this is MatchData region. I'm really torn on whether I should just call it MatchData, but then I won't remember that it's kind of a weird type that I don't really control. I'd rather it be a weird name here so that every time I use it, I kind of remember what it is. Okay, MatchData region. And so the way we create one of those is to, we're just going to copy this. I'm going to say MatchData. And what it's going to take is an environment and a Onigmo region here. And let's go down to here. We're going to say this is a MatchData. It's going to create a new one of those. It's going to set the type MatchData. It's going to set the MatchData region to the region, and then we're going to return the object. So pretty simple. Yeah, pretty simple. And then we'll copy this to Natalie H. Oh, right. Nat Regex, and we'll paste it here. So I think that's a good start. And then we need to make a new file for this. I like to keep these separate. MatchData.c. You can't even create a new one, so don't want that. In fact, I don't even know. Which method I want to implement. What's a good one to implement? What's the easiest one to implement? Nope, not offset. Begin? Nope. Really? What? Those take, end. Those all take arguments. I don't know what those do. 2a. 2a is going to be, what's string? Foo. Oh, how are we going to do that one? Size. Curious. Okay, size wouldn't be too hard because the first region has this, right? Has the beginning index and the ending index. Yeah, let's just implement size. I just want to get something working so that I can I don't know, have some peg to hang my my knowledge on, right? I don't know how to say that other than just got to start somewhere. Built-in H, and so we're going to say this, right, goes here. And then the way we'll create, yeah, I know, to do. So we don't actually have anything to create a match data, so I'll come back to here. What is this complaining? Yeah, okay, that's fine. So I think I want a regex match. Let's do that. Regex C match. I'll say this match. So I think I just realized that this equal tilde can be implemented in terms of a regex match. Rather than have all this duplicated code. I will come back to that. My brain's going too many different directions at once. So this region, we already created it. We already created the region. And we didn't even use it, right? Yeah, we just had to pass it in. So instead of, what does match return? I think I already know the answer. If it doesn't match, just return, oh, no. If it doesn't match, it returns no. So we still want this, so we still want the error. So everything is just basically the same here, except of what we return. So say nat object match data equals nat match data. Then we're gonna pass in the env and the region. And we return, can we, oh, we can just literally return that. There's nothing else we need to do with it, I think. Did I add it here? I did. Added it here. I have to add it in main.c. Match. Okay. Why is that so simple? I'm definitely missing something. Okay, fair enough. What was this returning before? It was returning the results before. Back to here. This number should always equal this number, so I don't even need to care about storing that this result. Hopefully. I guess what I'm saying is I think I can make our existing test pass by literally just doing regexp match. This is the match data, env self, arg count, args, keyword args, block. So just pass all of our arguments directly to it, and then we'll grab out, I'm going to assert that that is always at least 1. It's greater than 0. I probably don't need to do that, but I like to be a little bit paranoid. So this is what we want to get. We want to say if it's nil, nat type match data equals nat value nil, then just return match data, which is nil. Else, I don't know why I have 2 of those. I want to assert that the number of regions is greater than 0. And then I want to grab match data region. Oh, not num regions. What was it? It's the region beg 0. Region beg 0. Beg 0. That should be the integer that matches the start of the match. So if I did that right, then our regex test should still pass because this checks for the number to match. And I'll run make. Didn't like that. Oh, it's not going to compile with that. We'll just return nat nil. Okay, make cool. And we do Natalie test, Natalie regex test.net seg fault assertion failed. As a string or a symbol, add a reader. Module C, line 48. What? Well, fun times. I don't actually want to run LLDB or GDB right now because it crashes my recording every time. So I'm going to try to debug this without doing that. But what? That type name object. What did I change in this one? Added a new file. Curious if I put that back, does it change at all? Result. Okay, so if we take this and we put it here, and we say this is an integer env result. So that's basically the code we had before. Oh, I know what it is. Sometimes just doing actually pretending like you're debugging and thinking it through helps you figure it out. So I need to run make clean because I changed the struct. I changed the structure of it, and that moves memory stuff around. I'm pretty sure that's it. This has bit me before, and I've lost lots of time doing it, so I'm pretty sure that's it. Natalie. Ah, looky there. Okay, so that's with our new code. Just to make sure I'm actually testing the right thing. Oh, gotta run make. Let's do this. Make. Nil should be equal 0. Yeah, okay, so I didn't break any existing tests. That's good. And so now I've implemented this equal tilde in terms of, on top of regex match, which is great. We're already using our match data, and let's get match data size to work. So regex test, I can't type. We'll just do describe match, to say that actually let's just do describe size. It returns, wait, is that what I said I would implement? Size? How did we decide we would do size? Oh, it's the ending number minus the beginning number, I think. Yeah. So the size of the match. This is going to be broken when we get to Unicode later, but right now it's just going to be size of the byte size, and that's fine. Results. Let's see. Match equals foo dot match foo, and we should know that the size of match should equal 3, hopefully. Undefined method size for match data. Okay, making some progress here. Test driven, love it, love it. Main C, we don't have a size method, but we'll just make one. Match data size match data data size, and match data C. This is going to return nil. That's great. We love that. Wrong number of arguments given 0 expected 1. Oh, yeah, because we actually don't expect any arguments. Cool. Nil should be equal to 3. Okay, good. So the size I wonder what type do I use for integer? It's a 63 bits. Yeah, I don't think I ever made a video about how we did tagged pointers and 63-bit numbers, but I'm going to use this type so that everything matches. So the size should equal self match data region reg. And speaking of that, I'm going to do that same assertion because, like I said, I'm kind of paranoid about data not being right where I expect it to be. So I'm going to, later on, I think I'm going to make it so we can compile these assertions out. So it doesn't hurt to throw them in. It'll slow things down a little bit, but as we're doing development, it's just way easier to know that everything is exactly like you expect it to be. So it's going to be self. And I did it over here. So match data region, beg 0 and end 0. Is that what it was? Beg and end. Yeah. So it's going to be end minus beg. End 0 minus self match data region beg 0. That should be the size, and so it should be able to do nat integer env size, and hopefully that makes our test pass. Perfect. And we'll do another test with something a little more interesting, like foo bar baz. Oh no, that's not actually what I want. So let's make this match bar, and this is foo bar baz, and the match should still be 3 if I did everything right. Yes. And then just to make sure that groups don't affect anything, this should still match, but it should be 3. Yeah, it should be 7 because there's a space in between. Yeah, I think. Okay, perfect. Okay, so let's go ahead and add that to our index so we don't screw anything up. What's another method that we could implement? Ooh, interesting. This returns the original regex. How much do I care about that right now? Oh, and of course, length is going to be the same as size. Wait, what? Oh, no, I did that wrong. VR test support. That's not what the size method does. I guess it returns the number of captures. Okay, well that was even easier than I thought. So this test should fail in Ruby. Assembly regex test. Yeah, 1 should be equal to 3. Okay. Well, sometimes you make assumptions and they're wrong. So return the number of captures, including the whole match. Okay, so this should be 1, this should be 1, this should be 2. Right? So that passes in Ruby, and now it fails in Natalie. Okay. So we'll just go fix it. This is just num regs, right? Why even bother with that? Return nat integer env. So now does it work? Cool. Okay, add that to the index. And we'll get the length. Look at the length method for free because it's just an alias. Length, number of captures. Oh yeah, so I kind of forget about this sometimes, but if you do use the entr, enter, I call it enter, but I don't know really what it is. You pipe it a list of files and some flags. I use C for clear and S for shell. Test Natalie regex test.net. And what it will do is watch those files, and when they change, we'll run your command for you. So if you find yourself doing up enter a lot, command tab up enter, then that's super handy. So question is why? Oh, right, because I'm not actually calling length. So that should fail. Oh, I didn't give it the right number. I didn't give it all the files to watch. Nat. Okay, so that should fail because length is not a method, but that's easy to fix because we're just going to alias it here. And that passes, and so we're on a roll here. We're making things happen. Guess it needs a copy of the original string. So if I do this, I do 2s, I want it to return what matched, right? Foo bar baz. I want to return what matched. So 2s would be a good one. So let's just copy this. 2s returns the matched string. Match to s should equal to foo, and to s should equal bar, and this one should equal bar baz. So that one should definitely fail. Okay, and let's go implement MatchData to s. Takes no arguments. We're going to make sure to do that same assertion. And this is where I'm going to need to look. This region, I mean, I'm sure it doesn't store a copy of the string or a pointer to the string. But we could go look at this onig region. This onig region struct, which is re registers, and yeah, I don't, capture history now. Okay, so it's almost certainly not pointing to the original string in any way, and it would be very surprising if it did. So what we need is a pointer to that object. Curious, in Ruby, okay, so let's say I have a string that is foo bar baz, right? And I do match bar. And I store that in m. And then I change the string. So if I do 2s, it's returning bar. Yeah, now if I change the string, let's see, 0, 1, 2, 3, 4 through 6 to say Tim. Now the string reads that, and I do M2S, it equals bar still. So it's duplicating the string. It's not just a pointer to the string, which is good. Good job, Ruby. You did the right thing here. So we're going to say this is a struct because all these things need to be stored. And we're going to say this is I just did str above, so I'll do that to match str. So if we store a char pointer here, we're going to need to copy it in. When we go here, which means I need to pass it in here. Yeah. And then I need to fix it over in here. Nat match data. It's going to be pointer string. So when I create that, regex c match, I need to pass in a copy of the string. So the question is, do I copy it here? Or do I, which function has the responsibility of copying that? Let's do it here. And let's make this a nat object. I can't really tell you why, other than it just feels right and it's what I want to do. I don't know. I have a function called heap string, which basically just makes a string copy. Yeah, so I'm just going to use that to make the copy. I am going to do an assertion, nat type, nat value. Like I said, I like to be a little bit paranoid. Why is it not there? Yeah, so, oh goodness, go away. Regex. So here we're going to pass in the string, which is arg0, and rather than refer to as arg0 everywhere, we're going to do string obj, nat object, string obj equals that, and okay. Now we have a copy of the string. We can do all kinds of fun stuff with it. None of that should have broken any extra tests. Okay, so we still have just that one test broken. Perfect. I did add something to the structure, so let's do clean nat make build. Okay. Perfect. Undefined method 2s, match data c. This is our 2s. Okay, for now, let's just return self match data string. This takes an env. No, it doesn't. No member name match data. Oh, underscore. Okay, still no method. We'll go to main C. Match data 2s. likey, built-in H, gotta copy it here too. Cool. You can see. Foo bar baz should be equal to bar. Okay, good. So this was obviously wrong. I was just trying to get something going. What's the what's the most efficient way to just grab the parts that I want from this? I'm gonna do some pointer manipulation. And yeah. Yeah, so let's do this. Self MatchData region bag of the first one. So that'll get the character, and then we get the address of that, turns it back into a pointer. So that gets us somewhere, right? This should say bar baz. Now let's just truncate it. String object string length, which we store on the nat object. We'll say this is this minus this, but this is, let's see, end. And then we'll put a null character on the string. So we'll say that equals 0. Does that work? Yes. Probably need a helper for this. No, it's good. I like it. Okay, one more, and then we'll wrap up for tonight. I want to be able to get the capture group, so we'll make this work. So in Ruby, if you do let's see, Tim Morgan .match MO RGAN, those are capture groups, and if I do 0, it's the whole thing. If I do 1, it's the first capture group, 2 is the second, and 3 is nil, and so on and so forth. What if I give it a negative number? What does it do? Oh, it's from the back. Well, we may not do that. Returns a capture group. So I'm just gonna start with this longer one here. Foo bar and baz match 0 should equal foo bar and baz. Match 1 should equal foo. Match 2 should equal baz. Match 3 and above should equal nil. Undefined method, yep. Okay, so in MatchData, we're going to implement this method. I'm calling it ref. Everywhere else, we'll call it ref. Built in, we'll put it over here before I forget. Make sure it takes an argument. Make sure the argument type is an integer. And then we're going to say if args0 nat int value. If we're asking for 0, then we're just going to call MatchData2s with everything. Self 0 args, null, null, and null for block. We're going to make sure that it's greater than 0 for now to do accept negative indices. We'll do that another day. And then rather than doing this every time, we'll do index. Oh, I thought, yeah, there we go. Index, if it's 0, then do this. If it's less than, actually, if it's greater than or equal to the number of regs, numregs, which is self match data region numregs, then return, oh, do return here, nat nil. And then last is we do something interesting. So, you know what? I shouldn't have deleted that. It's going to be a lot like this. So the string object looks like the original string starting at that index, and then we're gonna truncate it and add the null character, and that might actually work. Holy moly, it works. People, this is awesome. Cool. Well, nothing too spectacular. If you got this far, thanks for watching. Just to make sure I didn't break something else, we'll run all the tests. But yeah, thanks for watching. Like I said at the beginning, I'm still just amazed that people are interested in this. Other than me, I'm kind of a weird guy, but I'm glad to have you along, and hopefully you learned something. So as soon as this passes, I'll sign off. Running the tests. Boom. Okay, well, our Ruby regex or regex implementation has just got a little bit better, and I'm going to keep working on this. I may not make a video about every method I add because it's going to be a lot of the same stuff, but yeah, we'll keep working on it. So thanks for watching. See you next time.